Okay, this is Old Electronics Fan, and this is my Philco 38-7 radio. And I played around with this a little tiny bit. The knobs are off. Talk. All right. That's interesting. Oh, there's rubber feet that go on this. That's why it's not. Okay. So, I had bought this radio, and we had a radio club meeting, and I mentioned it, and they said, "Oh yeah, I'm familiar with that radio. It's a pretty neat radio." And okay. Well, anyway, I know that radio. It's a unique radio. One of the club members said, "Well, it doesn't perform well reception-wise, but it's a nice sounding radio." We'll find that out. So the front of this is in pretty good shape. It's missing. There's a piece of trim here that is a bit the worse for wear. It's a little twisted and broken off. This is going to be something I have to look around to see what I can find to replace that with. So that's minor, because the rest of the radio is pretty good. So anyway, so the top of this is not great. Maybe I should just grab my camera. And the side, it looks like water. I'm kind of puzzled because it looks like water got into this and took the finish off. But what I don't see, and this is the part that puzzles me, is I don't see water damage to the top. And then let's go this side, and this looks perfect. The finish is missing on the very top of this, but as far as this goes, it looks awfully nice. So I'm a bit baffled. And then you have this. This is the back side of this, and I can't tilt this too much. It's got a dynamic speaker. That is off because I took it off. Because I want to take a look at something on this. And when I first got this, let me swing this back around. Well, yeah. Before I can take that out. When I first got this, I was a little bit concerned because this didn't move. It was pretty solidly stuck. So I wanted to see what was going on there. So I did slide it out of the case, and a little lubrication and a little persuasion, it decided that it was going to play nice. So that is about the extent of what I've done to this. I've had that's taken the chassis out of the case, fixed that, put it back in the case, and it's just sat. So now we want to take this case out and take a look at what's going on inside, because I really don't know anything about this. I was just looking at one of there's a rubber cushion that's supposed to go on here, and I think when I took this out they kind of fell off. They're not in very good shape, unfortunately. And I think there's probably places where I can get replacements for these. They still feel soft and squishy, but they're definitely cracked and not all that good looking. I didn't think to look for any of those while the radio was sitting around, so. But regardless, so there it is. It's a little bit rusty. See rust on there. And I might touch this up. One of the things I don't tend to do is I don't get into refinishing the chassis. It's a lot of work, and Now I might try to clean up this rust a bit, just to keep it from rusting further, and I might repaint this transformer. But beyond that, I'm not going to try to restore the case or the chassis. It's just not something I tend to do. This radio is probably going to be sold. I like it, but my problem is I don't have room for all the radios I'd like to keep. I have some of the ones that I've decided I do want to keep around, and those are taking up shelf space, what limited shelf space I have. But this one, it's kind of big, for starters. I saw the picture of this. I liked the look of it. I didn't know much about the 38-7, but I liked the look of it. So I decided I was going to go check it out. And I was shocked when he brought it out, because in the picture it seemed like this was a lot smaller. But I decided that I wanted to get it anyway. I thought I'd go ahead and do that, because I thought it was a pretty neat radio, and I still do think that way. So the next step is to slide this out and take a peek underneath. Let me just see if I can slide this out. Now I did some of the controls that you saw missing on the front. They're not missing. I do have them. All right. Let's see. Well, inside here, my case is coming apart. This means that this has spent some time in damp places. The other thing, I was going to show you this. Oh, more parts and pieces. I gotta find out where that goes. Yikes. All right. I'm kind of glad that I had this piece of material underneath it, because, well, that's a mess. Let me get to what I wanted to show you. The top of this. Little white specks all over the place. Now I've touched this up a little bit with some glass cleaner just to see if they would come off. It looks like they do. My goal is to clean this up a little bit and revarnish the top of this, because otherwise this thing is in pretty good shape. Look on the side. Now there's a strip here I'm going to have to replace. That strip is here, and as you can see, well, moisture has been broken. It's been broken. The end's been broken off. So this is pretty tired. So I'm going to try to come up with something to replace that. But otherwise, the finish is a little bit cracked. But I already know how to deal with that. The side, well, yeah. There was moisture involved at some point in the life of this thing. Let's see. Can I? Yeah, I'm gonna have to dump that out somewhere before I get into this any further. All right, let's see if we can. I don't know if you can. I can get you to see what I'm seeing. Okay. Let's see. Can we get in there? The camera always looks like it's washing things out. All right, but I never know. All right, so there it is. It's showing me the tubes I've got in there. I've got 6K5, 6K7, 6J5G, 6A8G, 6F6G, and a 5Y4G. So that puts this, and the Philco speaker, which is what this is, puts this firmly back in the late 30s, early 40s, probably. This radio has sat for a very long time. It's got quite a collection in there. A vacuum, I think, is in order. Okay, so I see where this couple of my pieces used to be. Fortunately, I've got a good, very strong wood glue that take care of that. So we're going to put this aside for a moment and we're going to look at the chassis. Alright, so, well, let me so I can get rid of this. Give me a minute here. Alright, I've repositioned it. Come on, you. Untangle. Alright. Well, not too hard to see that we got a problem there. That is decidedly unhealthy. All that white stuff coming out of there. And it's on both sides. This is a wet electrolytic condenser made by Sprague, it looks like. Yeah. So, wet electrolytic condensers are prone to doing things like that. All the tubes seem to be here. I got 1, 2, 3, 4, 5, 6. One of the radio club members is very familiar with this, and I guess those who are have been doing this hobby longer than I have will be familiar with this radio. Apparently it's a nice sounding unit, but the downside with this radio is that it's not a strong performer reception-wise. That's what I hear, but that's okay. I bought the radio because I liked it. It's also, I found out after the fact, that it's got some unique features which we'll go into later. So we go swing this around. We've got another electrolytic capacitor. It says Philco on that one. And while it's not leaking out the side, I don't think it's trustworthy. So my transformer's down there, so we're going to flip it this way. Oh, there's my power cord. Gee. I wonder if that's salvageable. Yeah, right. Okay. Alright, so this has a Sprague atom. That could mean that this has been worked on at least once. Let's see. What on earth are you? I guess this, hopefully the schematic will tell me what that is. There's, looks like mildew on the paper cap. Let's see, I guess I'm not showing you everything, am I? So there's that little Sprague atom. Those do have a tendency to do better. It looks like it could possibly be original based on what I see from the soldering. But that's not a guarantee. Some guys are really good at doing that. The fact that the solder is no longer shiny leads me to believe that it's original. But down here, there's a, looks like mildew on there, which just adds to my theory that this thing was in a damp environment. And there's a little bit of rust hiding down in here. Just slide this back a little bit. I can't really get everything in there, can I? Alright. So, it has one of these capacitor blocks, which they're fairly easy to rebuild. Unbolt that, unsolder all your wires, dig out the stuff. You've got to be careful with these though. The walls on these are very thin, and if you pry against the wall, you will do some harm. I know, because I almost damaged one. Well, I did crack it slightly. Caught myself just in time. Oh yes, okay, so this electrolytic here is the one that's on, that wasn't leaking around the top, but it sure is leaking out the bottom. So, there is nothing, none of these capacitors in here that I think would be safe to keep in here, given the vintage of the radio and the condition there. And the ends seem to be blowing out on some of them. It doesn't look all that bad, all that great that way. Interesting to see how this one tests. I'm not sure I'm going to keep that one I'm probably not going to keep that one in there because I don't entirely trust those. And they're decent, but this is, I wonder if I have a date. I should look into this more. But the first thing I'm going to do is just chop this off so it's not my way, and I'm going to then, what am I going to do first? I think, oh, by the way, in case you don't know, and I'll have to show you this, but I have a chart somewhere that tells you what the part number on the side of these blocks, let me back up. The part number on the side of these blocks tells you what's supposed to be inside of them. And there's a chart somewhere that tells you, or gives you that information. I had that, a file on that somewhere. I'll have to look for it. But what I think my first step is, I'm going to take this apart, and then I'm going to show you how I go about doing this. Although actually the first thing I want to do, that transformer orienting this that way is not going to work for me. So can I put it on its back? Will that work any better? Yeah, I think that'll do. So I think the first thing I want to do, though, is take a look. Oh, that's the wrong one. I thought that was the schematic I wanted. Oh, it's hiding behind. Yes, there it is. Okay. Let's see if I can find out what that is. Okay, 47. So if I look on my chart here, it tells me that 47 is my capacitor block. And let's see, 47. Parts list? Yes. Teeny tiny print here. 47, condenser. Well, that's interesting. 0.015 dash 0.015 comma 25 microfarad. Interesting. Well, we're going to have to take a look at our circuit diagram and see if I can figure this out. So I know, well, here's the thing about these blocks. And depending on the radio, will determine exactly how they do them. But you notice you've got on this end, let me zip in there a little bit, and it never lines up properly for me. Alright. On this end, you've got a bolt that actually goes through the top of the chassis. And this is a ground, chassis ground. And I'm pretty sure that I'm going to find out that inside there is at least, well, let's find out before I guess. Power cord, where are you? Let's go to, okay, yes, exactly what I thought. Alright, where are we? Right there, if I can get my thumb, oh yes. Alright, so, there's your power cord. 0.015, those are across the line caps. And then in the middle there's a chassis ground. I'm not excited by that. You can get I've seen this on newer stuff, on some transistorized stuff, and having a capacitor going to chassis like this, you can wind up with still a little bit of AC voltage leakage to chassis ground. But we'll see how this one behaves. I'll check it at some point. But anyway, so, okay. Alright, that's just a ground connection. Okay, so that's what I thought. So inside that block are these 2.015s, so that tells me part of what I wanted to know. And it says 47, which tells me where those are. And I've got another capacitor, capacitor. It said it was a 25. Well, okay. Well, anyway, we're going to dig into this a little bit. Just kind of poking through this to see what I can find out. 45 electrolytic condenser. Alright, so what I'm going to do is I'm going to take this apart and take one side of this. In fact, I should get my soldering iron warming up. I will stop it. And then, oh, I'm just making a mess everywhere today. Joy. Well, that's one way to clean out your excess solder. Just dump it on the table. Okay, now, I'll get rid of you. I don't think that's worth keeping, since it's crumbling in my fingers. And I'm sure the wiring inside, with all that moisture that's been around, is probably dark colored. So one of the things I do like to do is take pictures. I've got my circuit diagram, but here's something important that you need to know. You can't rely on the circuit diagram. The circuit diagram is a good guide, and if you, oh, I want to crank that up more than that, and if you have confirmed that the circuit diagram matches your radio exactly, then you can trust it. If you have not taken the time to do that, which I have not, first time I've seen the underside of this, then you can't trust it. Because, well, there's a lot of reasons. First and foremost is that when manufacturers are building radios, they sometimes discover that there could be a part of the circuit that needs to be improved. Or they may have discovered, it could be improved. There could be a problem or something, or they have determined that a change of capacitor or something would improve the performance, solve an issue like squealing or something, whatever. So they change the circuit diagram, and as great as it is to have these, you can't rely on them 100%. Because things change, and I've seen people take the radios completely apart and then try to rewire them, put them back together based on their schematic, and some of them have discovered that, yeah, that's a problem. Well, unfortunately, I got interrupted. But while I was away taking care of some stuff, I realized that actually what I want to do before I go too far into this is to try to see if this radio works at all. Because I don't want to go through, replace all the components and all that stuff. Go through all the restoration and find out that the radio has major issues. But the first thing I want to do is take a few measurements. Alright, so I want to check and see if this is shorted in any way. That's okay. I don't think there should be any difference between there and there. Ooh. Alright, well I have a capacitor. Try capacitorizing. Is that a word? Probably not. So there's a capacitor between here and ground that's charging up. This is the on-off switch. Is this on? Oh, that's a band switch. Maybe that sounds a little gritty. see. Well, that is, huh, well, that's interesting. Oh, I bet that's the tone control. A lot of radios, the tone control had the on-off switch on it. Okay. Well, let's do this. Let's turn it on. Okay. I don't think it makes any difference. This is, oh, this is the one that goes to the, all right. So it doesn't show shorted. Let me see here. I'm looking at those capacitors and I'm a bit reluctant to put power on it, but they don't seem to be shorted. I'm sure they're going to hum like crazy because they aren't acting as capacitors anymore. That's K ohms, not meg ohms. That's not ideal. Let's see. Well, I'm going to put this on my, well, first I got to put a cord on it, don't I? Well, I don't see anything shorted. And yes, it does not mean that all is well and that things won't go wrong when I power it up. But this will be on my light bulbs, and I think that's what the next step we're going to take. In fact, I think I'm going to have to yank the speaker out of the case. And put a cord on it, and then we'll do a quick test to see if this actually behaves as a radio. Alright, so that's what I'm going to do. I'll be back. I'm going to put a cord on it, a temporary cord. I don't know if I have anything. We'll see what I've got floating around. I'm thinking, pondering, considering. Yeah, put a cord on this, grab the speaker out of the cabinet, and I will be back. Alright, I put the power cord on. I've got my transformer. I started it. I've started to bring the voltage up. Of course, as I was doing that, I realized that I forgot to hit my record button. That would have been annoying. So right now, I've got this kilowatt is set to watts, measuring watts right now. Normally, this thing draws about 70 watts according to the label on the case. I've got very low volts right now. I've only got one bulb in. Number 3 should be my 100 watt equivalent, which, because this thing draws a lot of current, that side is right there. Hear the transformer buzzing a little bit. I think. Oh, the speaker. Interesting. Well, it's a field coil after all, so that means there's voltage flowing through this thing a little bit. So far I don't see any lights, and I'm getting up to 60 volts, watts, power factor, volts, 55 volts according to this. 0.18 amps, and then 99 watts. So, I probably should have checked. That's what I should have done. Alright, here's what I'm going to do. I'll take this tube out. This is the rectifier tube. Come on, let's go. If it will let me. Alright, I want to take the rectifier tube out because I want to make sure that the power transformer is doing what it's supposed to be doing. So, alright, let's see, we need to, alright, so pin, alright, Alright, so yellow and yellow should be what's coming from the transformer, and then there should be a yellow-green wire going to ground. And then there should be two blue wires that feed the filament, and there they are. Alright, so we'll just see what we got. So I want this on volts, and I want it on AC. Alright. Okay, does it tell me what voltage? It does somewhere else. It tells me voltage. Okay. Well, this capacitor has 330 volts across it. Where's my... Oh, there it is, 5Y3. Alright, so across the heater, I should have 315 volts AC. And the heater is these two right here. But I'm going to check here, because right now, there is no tube. But let's fire this thing up, and let's see what we got here. .21 volts, alright. Let's bring it up some more. 25 volts. Really? That's a lot of watts. And not even at full voltage. Oh, that's volts, never mind. Watts, 9 watts. Okay, never mind. So right now, I've got 82 volts on here, but I have minimal transformer power. Oh, what? Ooh. Okay. Oh, wow. Alright, 474 volts. That's working. What do we got up here? This should be 5 volts. 3.7. Bring it up a little bit more. Almost 5 volts. And this is... Come on. Alright, we'll go there. 5 volts. Alright, well this apparently is a day for interruptions. So, what I want to do is, I've measured the transformer output, and that seems solid. So what I want to do now is I put my rectifier tube back in. So now I want to see what my plate voltage is. And when I look at this, thankfully there's a sheet that tells you stuff like that. On this is the output tube. And I'm going to use that as my measurement point. This is supposed to be, well, these two pins, one is 250 and one's 230. Now this one up here is supposed to be 330 volts. So we're going to go, and that's DC stuff, so we're going to go there. Alright, so here we go. And the other thing I want to keep an eye on with this is, oh, oops. Yeah, I want watts. So there's 10 watts. Alright. Alright, so right now I've got my 100 watt bulb in circuit, and I don't know if that's going to work any better. This is probably just going to go boom on me. It's probably going to fall down. I don't want you falling down. But nope, it's not going to cooperate, is it? Now we'll see. Alright, so we're at 8 watts. That's really low. And if I go from, well, first of all, let's go to see what we've got for volts. Actually, AC, 3643. Let's bring this up. We're going to go up here. I'm jumping way up here. But you notice my bulb is still not brightly glowing. I don't know. I guess I have to get a different way to position that so it's going to be visible. You can hear the thing humming. I don't hear any audio. Okay. That little capacitor looks like it's melting. Not good. Alright, so I bumped it up quite a bit. I've got one bulb in. Let's see where we're at here for my DC voltage. Up here, 176. That's about 100. This is all way, way low. Yeah, it's about 100 volts low. Let's bring this up a little bit more. And I'm going to add another bulb. And here the hum climbs up. So let's see where we're at here. Oh. 199, 130, and 46. What's this one? 75. Alright, so our voltages are way low. The only audio I have, this is the volume control as far as I can tell, the only audio I have is the hum coming out of the speaker. So what I'm going to do is I'm going to replace the electrolytics and see what we have at that point. There could very well be something else going on wrong, but I do see filaments on at least one tube, and it's the output tube, which is humming away merrily. Alright, so let's see what I got after I replace the electrolytics. I'm willing to do that much because at least I know I've got a working power transformer. It is producing appropriate voltages. My audio circuit seems to be working because I'm getting that nice hum. That means some basic stuff is functional. And I'm certainly willing to replace the electrolytics to see where that gets me. So that'll be the next thing I do, and we'll be back after that. Well, I've got the new components in. There's one thing I want to point out. There's ways to get surprised by things, especially when you're moving capacitors around. So I had to chop this one off and then mount this, and this resistor was not healthy, so we've got a new one of those, new to me, used. It's a lot closer in value than the original one, plus it's a lot shorter, significantly shorter, so I can make this all work. But anyway, this is the B plus right here. These two are your B plus. I'm sorry. Well, this is the AC coming into the rectifier that supplies B plus to these two wires. And normally, or typically, this part goes to chassis ground. But you want to notice something. This one does not. And in fact, this one of the capacitors that are part of the pi circuit are tied to this, so that the capacitor that was originally in here was actually insulated from the chassis, because it does not, the ground on that capacitor does not go to chassis ground. So just to be aware of that. And the other thing you need to look at, and I did look at this to make sure I got things right, when you're dealing with some of these filter circuits, sometimes you'll find out that the plus of the capacitor isn't here, it's down here. So just watch out for that when you're swapping out capacitors. Pay attention to the orientation when you're taking them out. So anyway, where am I at? Okay, so I turn that down. So I've got this. There it is. Okay. Let's see. I need to do something with this. I guess I have to make a stand for that. Hertz, VA, watts, 5.6 watts. All right, I'm gonna look at this with my Beckman. I decided that's more convenient, and because it has a stand that keeps it at the right angle. Plus, there are advantages to using that. All right, so this is the one, 40 volts. So what do I have for AC? All right, let's bring you up. Okay, let's see what we got now. 82 volts. Well, let's stop there. Let's go back to our DC. Let's see what we got for our voltage. Ooh, it's already better. 226, 225. That's way better, way gooder. All right, and I want to check this. See, 206 and 210. Okay, that's significantly better. I don't have any audio at the moment, or at least I don't have any. Well, one thing I don't have is hum, which is good. Bring this up some more. All right, 260. It's still a bit low, but it's okay. 223 or 4. And this one, 230. Okay, so that's looking a whole lot better. What was the voltage supposed to be on that? Just out of curiosity. 250 and 230, so that's very close to what it should be. So why don't I have noise? Okay, so that got rid of our hum. And let's see. Volume control. Used in 3.7 only. Whatever that is. Like that. And I should have. Where's my. What pin is. It's not going to tell me, is it? Grid. Let's see. 6J5. There's my audio chain. So the center pin, I should have nothing. That's bad. Tube is glowing. Nothing. Silent. Why for are we silent? Because our plate voltage is pretty good. Bring this up some more. So it sounds like we've got other things going on here than should be. Alright, let's just check something out. It's hot, but it's okay. Let's see. Check this. 292, that's almost what it should be. 30, okay, so that means that resistor, this is a used resistor, so I didn't have anything else. I'm checking though, and so the resistor is not open, so that's a good thing. So whatever voltages are being supplied there are definitely okay. 30, 270, yeah. All those new capacitors are definitely making a difference. This guy, this for all intents and purposes open. I think it measured out to be 0.002 microfarad. It's supposed to be 8, so that's dead. And of course the others were not good either because they were humming away like crazy. Alright, so Now I see a lot of corrosion on that audio tube, so it's possible that that's what I'm dealing with, and that it's not another failure somewhere else. But let me just see something. I want to, my output tube is a 6F, well, first audio 6K5. Oh, where are we? Oh, alright. Alright. Well, what I'm going to do is I'm going to pull that tube, I'm going to clean it, and I also do know the socket is loose, and if I have another one, maybe I'll install that, but I think I'm also going to check that tube, because it doesn't seem to be doing anything, although it was humming pretty well earlier. But I tried to grab the tube earlier, and I was trying to get it to move, because I didn't like all that corrosion on there, and that's when I found out the socket is, or the glass part of the tube is loose in the socket. So I don't think I damaged it at that point. We're going to find out with the tube tester, and then we'll go from there to see what we've got, what we got to do. I'll be back. Well, this one is clearly showing me why you don't want to run these things for long with bad capacitors. This is the grid of the output tube, and right now when I touch it I get a hum. The minute I tap that against the its connection, it shuts off, and let me see if I can show you why. It's over 100 volts on that, through that capacitor. I'm surprised it didn't roast the tube. I tested it on the tube tester and it says it's okay. Just okay. So that capacitor's got to go. And let's see, what else have we got? Well, I've got another audio tube here now. Alright, so that's coupling between this plate, which has lots of bolts on it, and it says that it has 6K5, 170 volts. When I measured this, I had almost 120 volts. There's only 170 on the plate. That thing's a resistor. That's not good. I really should have checked that earlier, and I just got sidetracked and didn't. Well, anyway. So, now I'm looking at, and I looked at the voltage that's supposed to be on here, and it's supposed to be negative 16 volts or something. The circuit diagram doesn't tell you that. It gives you some voltages, but it doesn't tell me what the grid voltage is supposed to be. So I got that from my tube manual. So, minus 16, it's about 130 volts too high. Almost 140 volts too high. So, anyway, so I know this is killing my audio. I don't know what's happening with this one, because I don't have, well, actually, I'm going to replace this, and then we'll see if I get any signal from the radio part of the front end part of the radio. So, so that's going to be the next thing I'm going to do. When I come back, hopefully we'll be getting a little bit further toward getting this radio to actually play. That has got to be the worst paper capacitor I've ever run across. That's horrible. Alright, well I'm going to bail out right here, and we'll be back. Okay, I've replaced this capacitor, and while I was in here, I checked this resistor. Whatever I did with the other one. Was bad, so I replaced that one. that one's supposed to be a 1 meg, and it read around 4 megs, so that was just a wee bit off. I don't know, oh there it is. This thing right here, well, let's just take it out here out of the circuit. I think I already had it cut when I was testing it, so I should get the same reading. Let's see. Get that out of there. I guess that's okay. Alright. Or not. I have to be able to see it. Alright, let's see. Oh. Yeah, 3.1, thereabouts, 3.2. So, this is a resistor that I think this is, the color code on this is the same as the dog bone resistors, because it's the only thing that makes sense, because it goes body and dot on those. And if you go body and dot with this one, so it's brown, 0, and then green, my memory fails me yet again, green should be 5, okay, so 5 0 6 zeros. Yeah, so that should be 1 meg, and so that's what the circuit diagram also says. As you know, I don't entirely trust the circuit diagram. So, yeah, this is 3 times the value it's supposed to be. Dead. Now, I was curious about something. Let's see, 20 megs. I usually don't bother even trying to put a digital meter across a paper cap. So I'm going to, just for the fun of it, hook this up. Alright, maybe. There we go. Let's see what we got. Okay, well, interesting. I said well, for you a few minutes ago, I said this is more like a resistor than a capacitor. My meter, this digital meter is actually reading this as a resistor, and it says it's about 45 megs. Now, up here, I have my volt vacuum tube VTVM, and I've in a previous video showed people how I test these. And I want to see how this looks compared to that one. So this is about 50 megs. Now some people would say that this is okay. But let me show you what a new one looks like. And you got to watch closely because it goes by quick. Bink. And it goes right back to infinite ohms. That's what a new capacitor does. This is brandy new, same value as this one. Now, the reason I bring that up is that, oops, this, if you measure this with a voltmeter and you get a 50 megohm reading, you might think that this is okay to continue using. Well, this is the capacitor, the coupling capacitor that was letting 120 volts go through to the grid of this tube, which was well on its way to roasting that tube, and I hope I didn't harm it by running it as long as I did. But anyway, so when I use my vacuum tube voltmeter, if a capacitor doesn't measure the way this one does, if a used capacitor doesn't measure the way this one does, I consider it untrustworthy. And this is a perfect example of why I consider this untrustworthy. Now, is it possible that some used capacitors that measure 50 megs are fine? Yeah, that is. But there's 2 factors. Number one is how much voltage is on it. And number 2 is what kind of shape is the capacitor really inside, which of course we can't see. So what could be happening is this will read 50 megs on my vacuum tube voltmeter. It's actually reading 45 megs on my digital. But when you put high voltage on it, it breaks down. So that definitely means that, well, here's my policy. Any capacitor that has high voltage on it, and any capacitor that's in a coupling capacitor position in the circuit, gets replaced if it's one of these old paper capacitors. It's not worth risking a tube to save a buck on a capacitor. It just isn't. There are some radios where I haven't replaced the capacitors. Imperial imp capacitors, black, they look like black beauties, but they're not. They're far superior. Those capacitors typically test like brand new when I test them. If they are not in a coupling capacitor roll, and if they're in a low voltage circuit, I tend to leave those behind because they're testing new. I can see virtually no difference between one of those and a brand new capacitor. So you can take that and do with it what you will, but that's my approach. And I may at some point regret that, but I don't think I will. Alright, so now, where are we at? Oh yes. So I've replaced this and this, and oh, the other thing I wanted to do, I want to do a quick test. This is a coupling, or this is, yeah, well, it's kind of a coupling capacitor, but it's not high voltage, I don't think. Oh, is this, I don't think that capacitor's any good. Yeah. I may be replacing another capacitor. Well, what I'm going to do first, because I'm pretty sure this is low voltage. Let me put this on. I'm going to set up my meter so I can do a quick test of voltage on that, but I don't think it's high voltage. So we may just let that one slide for the moment, but it is going away anyway. So I think, but when there's also, in the tone circuit, there are capacitors in here that are definitely going bye-bye. There's at least one in here that's part of the tone circuit, and I'm getting rid of that one. Let's see, it's on, off. Oh, okay, so the connections are on the back, so I can't see them. Alright, so I think, is this on? Alright. And we'll start off low, put this back. Now, one of the things I need to mention, as I'm sure some of you will probably be thinking the same thing that I think you're thinking. Alright. And that is, well, why are you using a, now let's try this. This isn't mine. I know you can't see anything. So why am I using this when I've got the bulbs? Well, the bulbs give me a good visual clue that something bad is happening. If I turn it on, and immediately it goes to full brightness, and it stays there, then I know I need to shut the radio or whatever I'm working on down and find out what's wrong. What I was doing with the with this, looking at watts, that was curiosity more than anything. I wanted to see. Of course, the watt meter isn't accurate when you've got a bulb in the circuit because the bulb is absorbing some of the watts. So, plus the other thing is, it's kind of nice to, so that looks good. So this means this is on, it's drawing current. It's only 22 watts. Let's give it some more watts. Maybe. There it goes. Alright, so I've got 200 volts DC, very low voltage. What have I got here? Too much. 300 volts, okay. So I've got stuff. Alright, now let's see. If I go here, I should have hum. Well, it's making some crackling noises through the speaker. I'm not getting anything out of it. Okay, so when I tap this, I do get some noise there. Alright, so what have I got here? Whoa. Oh, let's put this down here now. It's minus 8 volts. Now my tube chart told me that this should probably run around 16, negative 16. But negative 8 is definitely a way better number than the 120 I was reading there, which is horrible. Alright, so I don't seem to have any noise coming out of this. Let's I really think I want to put something on that nothing, deader than dead. Nope, okay. Well, we have more problems going on. Alright, so I'm getting static when I move the tone control. And actually, let me put this back here, put this up here, because I want to see. Yeah, that's really low volts. What's this? It's also low voltage. Yeah. So these capacitors, while they may be leaky, probably aren't doing bad things. So, alright. So, now while I was trying to figure out what was happening here, I tested this tube, it checked okay. This tube checked poor. On one tube tester, and on my other simpler tube testers it said the tube was fine. Which thing is true, I don't know. So so the question now is, what is going on? Why is this radio so quiet? Now the other thing I didn't do is I didn't check the IF coils or anything like that, so I'm hoping I don't have a problem with one of those. Given that there is some corrosion in this, I suppose it's possible there's a problem there, but I do not know. So what I think I may do is dig around in this a little bit more and try to find out what, if anything, I can see. The fact that I've got crackling in the speaker leads me to believe that this tube is indeed working, and if I go here, it makes noise. So, but I go here and it's nothing. So it looks like somewhere between here and here, we got no noise. We got something is not working right. So we've got this tube, we've got this tube. Now, the other thing I need to mention is that when taking this tube out and cleaning the pins and cleaning the socket made a difference, because this was absolutely completely dead. Well, actually, it wasn't completely dead. I was getting humming. But once I cleaned that and put it back in and cut this capacitor, then I was able to get clicking out of it when I was moving the tone control, and I wasn't getting that before. So I think I had multiple problems. I had dirty pins on the tube socket and on the tube, of course, with this capacitor, putting 120 volts on there, trying to roast that tube. That was bad. So, alright, so I got to dig into this a little bit more. Oh. Okay, well that's interesting. If I play with this, I'm getting static in the speaker. So that definitely implies that the audio chain is working all the way through this tube. Where am I? Which one was I on? I was on 6K5. Alright, so it's from the 6K5 onward, I have sound. So, the next thing is I gotta find my 6K5, no, 6J5. Oh, there it is. It's this one down here. And the grid is down there, I think. No, I'm not getting anything out of that. That could mean a dirty tube socket. Yeah, I see lots of corrosion there. Alright, so my next step is to take that tube out, clean the socket, test the tube, and then see where we go from there. But it's encouraging that the tube tester said it was bad, at least isn't so bad that it doesn't work at all. Alright, I shall be back. Well, this gets more and more interesting. The socket was loose. I didn't know for sure if I had a broken wire in here or not, but what I did know is that when I moved this around on the tube tester, the needle would move, indicating a bad connection. And I don't know, let's see here. The problem appears to be that these don't seem to have been soldered very well. This one has barely any solder on the tip. So does that one. In fact, they all have very little solder. And this one is actually corroded. So it would appear, I guess I'm kind of shocked that it worked for as long as it did. Of course, I don't know how long this radio's been sitting, but indications are that this radio's been played quite a bit. There are different brands of tubes in here, which means that this has gotten some use. And this one happens to be an RCA. This is a Philco radio, and I don't know what they usually put in here, but I see Radiotron, Kenrad, I don't know what that one is. So there's different ones. So what I did with this was I put a little mark here, and I put a mark on my base somewhere. I'll find that. And then that gives me the alignment that I need for putting this back together, I hope. And yeah, there's the line. So I can put this back together, so I'm going to have to be very careful as I'm cleaning these, and they do need to be cleaned, that I don't bend them and knock them out of place. I'm kind of surprised. I mean, you know, I guess any big company can have flaws in their production line. But anyway, so I'm going to try to save this. I don't know if the tube's any good or not, but I'm going to see if I can make it work. Certainly with those kinds of connections inside there, that's not ideal. So I'll be back. I'm back for a minute. One of the problems I ran into with this was that even though I cleaned this as carefully as I could to try to get fresh copper there was still some corrosion on these wires, and I wanted to tin them before I put them up in there, because I'm not going to see if they're actually accepting solder. So when I tried to solder them, it didn't work. Fortunately, I happen to have some rosin soldering flux, some people scoff at using that. They say, well, if you have good solder, you shouldn't need it. Well, I've got decent solder, and the only time I've ever run into problems with getting it to solder is when I've run into something like this, where you've got corrosion. And I think you can probably see, hopefully, that the tips are indeed now soldered, and that wasn't happening before. I just didn't want to go. So now my next goal is to try to, well, and the other thing that you might want to see is, I don't know if you can tell, there's holes in the ends of these pins, and you say, well, so what, they're hollow. That's how it looked before I took this apart. There wasn't, the solder hadn't been forced down into the pins enough to really make a good solder joint for this. So, well, it kind of was a surprise to me, but because this says RCA, of course, who knows who made it, but anyway, back then I assumed RCA was making their own stuff, so maybe they were, maybe they weren't, I don't know. So my goal now is to get this oriented in there and then placed. I got to see if I can clean up the old solder here somehow, and get these in place and soldered properly. Of course, I'm not entirely going to be sure, but what I am going to try to do is, I've got a thinner solder that I hopefully will flow down in there easier once I get this cleaned up, and hopefully I save this tube. This tube may be junk for all I know. It didn't test all that well on that tester, but the other tube that didn't test that great is actually working apparently, so I'm not sure if, I don't know what's going on. So I'll be back. Alright, well, I skipped over a couple of things. They weren't necessarily exciting, but basically the fact that this thing was quiet was due to the fact that a number of tube sockets were very corroded. So I noticed this one was, I cleaned this one, and this one I showed you repairing the loose socket and the unsoldered wires. This radio now plays. It picks up short wave at least. I'm not sure if somebody got in here with a screwdriver and started twiddling with the AM side of things, or if there's something else going on. Alright, well, it's been interesting. The volume control is working great, no longer staticking. And I've got a signal generator hooked up to it because it's not receiving channels. So I'm guessing possibly the alignment's way off. But at least now that I know that it's working, I can move forward. So far, okay. Oh, and I also had trouble figuring out which way this control went to produce, to give me broadcast. I now know turning the knob to the left gives you the broadcast band. I had to use my signal generator to find that out. There's also things in the circuit diagram that would have allowed me to track down what switch was closed or open when it was in the AM band. And I could have found it that way too. So I'm a little disappointed that it's not picking up stations. Actually, it picks up stations in shortwave. It picks up nothing in broadcast band. And I'm really hoping that it's not because one of the tubes in there is sketchy, but is a little bit weak. But it's possible. Like I said, this thing has been played hard. It's got at least 3 different brands of tubes in it, so it's had tubes changed frequently, it would seem. I don't know what else I was going to say. I'm drawing a blank. I'm pretty happy with where I am right now. I've worked my way through the issues that stopped it from working at all. Oh, here's something that I want to mention, but I also want to mention it with a caveat. These tubes, especially this one one of these two, yes. This one was really, basically the pins were locked in. They were not letting go at all. I actually had to get this in against this pin sticking out and put pressure on it, and as I gently rocked the tube, and one of the things that made this much more difficult, actually let me show you, and I was really concerned. This was the tube that I had to repair. I had to take the tube completely apart. Ew. Alright, I put that back. Oh, this. Alright. So both of these have this base. Oh yes, this is the one. I've got tape on there temporarily until the glue sets to make sure that the base and the glass stay together. This simply was not going to come out. It just was not going to budge. I tried as much, and this is all you've got. This right here, this part right here, that's the socket. That's all you can get to. And it's just, with the amount of corrosion there was on the socket and on the pins of the tube, I was really questioning whether I was going to be able to get this to come out. And the way I did it was I pushed in on the glass envelope so it stayed in the socket, and then I used this to push out. I use this to push out on the pin. Now you've got to be careful about that, because one of these, I think it was this one, or this one. Yeah, it was this one. It doesn't matter. One of these didn't want to come out, so I was putting a fair amount of force on this, and when it started moving I should have let off a bit more than I did, and all of a sudden it went bang, and the end of this hit the back of this socket, and I was really afraid I was going to be replacing the socket, because it's just made out of fiber material, and with the amount of force I was putting on that, there was a real chance of me cracking this. Thankfully I didn't crack it, and I didn't bend the pin. That was close. So I've had, I think, all of the tubes out of this. All of the problem tubes with corrosion on them have been cleaned and are now working. And that one tube is the glue is setting, and hopefully by tomorrow I can take it out and remove the tape and then put it back in, and it should be good to go. I'm happy that I was able to save that tube. I don't know how good it is, and it's possible that my lack of reception is indeed the result of a weak tube. I don't, no. Oh, so the output tube tested on that one tester that says these other tubes are not so good. The output tube tested reasonably good, especially since I almost cooked it with this bad capacitor. I really should have checked this sooner than I did, but I may have gotten out of trouble. I may have avoided trouble. I guess if worse comes to worse, I know a guy who has a stash of tubes, and he'd be more than happy to sell me tubes for this, and I may take these tubes down to him and see what his tube testers say. But actually, before I do that, I'm going to replace these capacitors. I may try to do an alignment on this, and if that doesn't come out the way I want it to, if it does, it still doesn't. If it still doesn't perform as well as I think it should, then my next step is to see about some different tubes, probably. He's got a really nice tube tester, and I think probably we could trust his tube tester and what it tells us. So that might be my next thing, which will delay. Oh, and yeah, and I'm probably going to show you how to take one of these apart. It's not a big deal, I don't think, but I will still take that apart and give you an idea of what's involved. I think I'm going to bail out on this part for now, because basically at this point I'm going to be replacing components I know are bad. Get all these paper capacitors out of here. And then, and who knows, this may improve the performance a little bit too, because I know these are bad. I checked one of these, and it tested similarly to this one. I think it was one of these capacitors that went here. It tested very much like the one I replaced here. So I have no hopes that the rest of these are really working the way they're supposed to. So I shall return once I get to the point where, probably the point of replacing these. If anybody is interested, I'm going to go ahead and do that, and then for those who aren't, they can skip that part. Alright, I will be back.